Hello everyone. Today I'm going to be looking at quotient rule. So the quotient of two differentiable functions, say f and g, is also differentiable at all values of x where g of x is non-zero. So if you want to find the derivative of fx and gx, you can write like d dx of fx over gx. It's the same as saying fx over gx prime equals, now this is the formula, it's very important. In the numerator, you take the differential of the numerator times the denominator negative the numerator times the differential of the denominator divided by the denominator value, the function in the denominator square, provided gx is non-zero. Very important. So let's go ahead and apply this on an example. So our function is x squared minus 9 divided by x plus 2. So when we take the differential, clearly it's two functions, a numerator and denominator. So when you take the differential, you take the square of the denominator, which is x plus 2 the whole square. Then in the numerator, you take the differential of x squared minus 9 times x plus 2 negative the numerator x squared minus 9 differential x plus 2. Once you have written down the correct expression, it's just now doing differentials and algebra. So coming back here, so taking the differential of x squared minus 9 is going to give us 2x times x plus 2, then this negative, and then it's x squared minus 9 differential of x plus 2, which is a 1, divided by x plus 2 the whole square. Now let's do the algebra on the numerator. We get 2x squared plus 4x minus x squared plus 9. And when you add up the like terms, you get x squared plus 4x plus 9 divided by x plus 2 the whole square. Okay, let's do another example. So we have a function given by 4x minus 3 divided by x squared minus 3x. So to keep in mind the formula, what I normally do is I write like this. I say y equals, say, f over g. You will have to definitely memorize this formula. So y prime, that is the differential of y, I write it as g squared f prime g minus f g prime. Okay, now if you keep this in front of you every time, you will have the correct answers then. Okay, so let's start with it. Y prime is what? You have g squared, that means x squared minus 3x the whole square. You're going to take the differential of the numerator, 4x minus 3 differential times the expression in the denominator, which is x squared minus 3x, then the big term minus, guys. Okay, and then you have this whole expression. Keep this one. This is one expression, which is f is 4x minus 3 times x squared minus 3x differential. Now we're going to do the differentials. So 4x minus 3, okay, I can see there's a typo over here. So the differential is 4, guys. So there is a little typo. I can already see that here. Okay, then x squared minus 3x minus 4x minus 3, differential of x squared minus 3x is 2x minus 3. Okay, then you multiply, so you get 4x squared minus 12x cubed. Oh, sorry, 12x, oh, sorry, it was right. 12x, sorry, it's not an x squared, it is 12x, sorry. Then minus, you will have 8x squared minus 12x minus 6x minus 18x plus 9. So we get is 4x squared minus 12x. So let me do it here because there's a little typos here. So you have is 4x squared minus 12x minus 8x squared plus 18x minus 9 divided by x squared minus 3x the whole square. So your final answer is 4x squared minus 8x squared is minus 4x squared, minus 12x and plus 18 is plus 6x, minus 9 divided by x squared minus 3x the whole square. So let me write it in a nicer form. You have negative 4x squared plus 6x minus 9 over x squared minus 3x the whole square. Okay? Now, let's do some trigonometric functions. What we have learned so far are the differentials of sines and cosines. So here we're going to look at the differential of a tangent function. Now we all know a tangent function can be written as sin x over cosine x. So this expression, if I want to find the differential of tangent, is basically a function, a rational function with the sine on the top and cosine in the denominator. So let's take the differential y prime. So it's going to be cosine x the whole square in the denominator. In the numerator, we're going to have sine x the whole prime. Remember, once again, I'm going to write this one, f over g. So y prime is what? F prime g minus f g prime over g squared. So you're going to have sine x differential times cosine, that's in the denominator, negative sine x times differential of cosine x. So now let's take the differentials. You get a cosine x times cosine x, one expression, minus sine x times minus sine x divided by cosine square x. So on the top, remember, cosine x times cosine x. Remember we just did again. I will just repeat the same thing. It is cosine x the whole square. We write it like this. Cosine square x is the same as cosine x multiplied with cosine x. So it's cosine square x, negative with the negative positive, sine square x over cosine square x. Now remember, cosine square x plus sine square x is what? 1. And 1 divided by cosine square x. Now this basically means is 1 over cosine x the whole square. If you remember from your trick that 1 over cosine is what? It's secant x the whole square. So I'm writing it as secant square x. Okay, so we have learned the differential of another trigonometric function, tangent x, is secant square x. Very, very important, guys. Okay, now let's go ahead, do some more examples. We're given a function y, x minus 4 over x square minus 7, and he asked, what are the points at which the graph of this function has a horizontal tangent line? So find the points at which the graph has a horizontal tangent line. Now, we have done this kind of a problem earlier, but I'm going to still recall that when we say graph of a function has a horizontal tangent line, it implies that y prime is 0. That means the differential of this function is 0. So the first thing we're going to do is find y prime. As this is a rational function with a numerator and have a denominator, so we are going to apply the quotient rule. So once again, the quotient rule, guys, keep in mind, I'm writing it down every time, and you have to remember it. It's very, very important. In your exams, you're expected to know that. Okay. So y prime is what? X minus 4, the whole prime, times x squared minus 7 minus of, write like this, is x minus 4 times x squared minus 7 differential. So when I take the differential of x minus 4 is 1 times x squared minus 7 minus x minus 4 times 2x, and then it's pure algebra. You're going to have x squared minus 7, and this is 2x squared minus 8x. When you take the negative inside, you get negative 2x squared plus 8x. So what we're getting? Minus x squared plus 8x minus 7 over x squared minus 7, the whole square. Okay, Now, remember, we have to find where the points the graph has a horizontal tangent line. What does that mean? To find the points where the graph has a horizontal tangent line means y prime is 0. That's what it means. That means this whole expression, this is y prime, this is equal to 0. Okay. Now, so it means minus x squared plus 8x minus 7 over x squared minus 7, the whole square equal to 0. If you have a rational function, a numerator with a denominator, and if it is equal to 0, so basically it means that the top, the numerator is equal to 0. Right? Or if you think in the other way, you can look at this one as, there's another way of looking at it is minus x squared plus 8x minus 7 over x squared minus 7, the whole square equals 0. You can think in terms of cross multiplication. So it's like 0 over 1, so you multiply this with this. So the minus x squared plus 8x minus 7 times 1 equals x squared minus 7, the whole square equals 0. So basically it's the same thing. So this is the main thing for us. So you get minus x squared plus 8x minus 7 equal to 0. I don't like to have a negative in front of the x squared, so I've multiplied the whole expression by minus 1. And we get x squared minus 8x plus 7 equal to 0. And when you do the factors, x minus 7 times x minus 1, you're getting x to be 7 and 1. Now remember, these are the points where the function has a horizontal tangent line. Okay, now we have learned about quotient rule, guys. It's time for you to practice. So the first one is I've given around 4 questions. I want you to practice applying the quotient rule on these 4 functions, and then would also like you to have added more little difficult problems in the differential of quotient rules. So find the derivative of a function at a point. We did a similar kind of problem when we were doing product rule. You would do the product rule and then apply the value of the function at pi 6 and pi 4. Also similarly, more practice problems. You really need to practice a lot on your quotient rules and product rules. And then finally, determine the points at which this graph has a horizontal tangent line and equation of the tangent line to the graph of this function. Now remember, I have picked up specific questions so that these questions have you will have to apply quotient rule when you take the derivatives. Thank you.